Hello, hello. We are doing questions 66 and 67. These will be quick. These are kind of beginning of the school type of stuff. So we look at this data, and let's imagine actually doing it in class. I think that's the best way to explain that. So it says that we gave everybody a coin, and we flipped them. So let's say we took 10 people, 10 classmates, one person kept track and the other person actually flipped a coin, and flip it 10 times and you write down how many heads you got. So if I look at A, it looks like, hold on, 19 times out of 100 people got absolutely no heads. That would mean in a row, tails, 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 10 in a row, tails. So this one is like totally out of the question. This would be not a fair dice. We could almost, that's crazy. I also look at this distribution, and we know that the central limit theorem states that data that we collect becomes normal if we collect enough data, and that enough is 30. So if doing 100 trials, it should be normal. This graph, if I graphed the frequency, would look like a U. That does not look like a bell shape. Not even close. So I'm saying to myself, for the same reason, I really don't like B, because if I graphed it, that's uniform, right? It's almost the same exact output, and that's also preposterous. That's exactly not what would happen if we did this trial. So then I look at C, and I'm liking what I see. This looks a little bit more realistic. So if one group flipped heads and flipped and flipped and flipped and flipped and flipped, we'd expect them to get 5, because if you flip something 10 times the probability of heads, which is 0.5. So N times P is the probability, and that's 5. So what is the expected value? 5. And so we would have expected a whole bunch of 5s, but we also are expecting bell shape. And so this one feels a little more bell, doesn't it? It's got 24 trials. We got 5, which we expected a lot. And then a little bit fewer for 4, a little fewer for 6. That's 1 standard deviation from the mean. So I noticed something pretty interesting here. It looks like if 5 is my middle-ish, and I added 18, 24, and 22. That's about 64. So that kind of reminds me of, so 64% of the trials got the middle-ish part. And so that kind of reminds me of this 68, 95, 99.7 rule. And this is another reason why I really like C, and I'd be right to like it because that one is correct. Now let's look at D and E. Let's eliminate those. Again, looking at D sideways, it pretty much looks just uniform but wiggly. So it's 7, 10, 6, 11, 8, 10. It's all over the place, but it's uniform, and we know the data needs to look like a bell. And then this data is curved, but holy smokes, it's really, really, really steep. And that's almost 90% of the data falls right at the mean, and that's not really the distribution we were expecting. So we're going to settle with C and move on to the next question. 67 states, the student government at a high school wanted to conduct a survey, and they wanted to do a simple random sample of 60 students. Which of these explain a simple random sample? So if you miss this, you need to take some notes. You need to write on your paper, simple, underline, simple random sample, and let's take a look. You should write down, what is the definition of simple random sample? It is when every single student had an equal chance of being chosen. Let me say that again. A simple random sample is when every single person in the sample had an equal chance of being chosen. Now, you can design a study that's stratified, but it's not an SRS. You would do a small SRS in each stratification, and that's okay, but it's not an SRS. It's called a stratified random sample. So I've eliminated C because that's explaining stratified, and I'm eliminating these others because of this word. I'm going to take the first 60 now. That did not mean everyone had an equal chance of being chosen. It meant I was completely picking the first 60 people. Every 10th person, that does not really allow each person an equal chance. It's going to be slightly off. Also, maybe certain types of people come into the room first. D, they use the word until again. I really don't like that. That means I pick until I get 60. And that means any student that came after that fact wasn't going to get a chance of being chosen at all. So E explains exactly what I'm looking for, which is E explains putting every single person in school from the roster in a table and randomly selecting those numbers. Thank you for joining us.